Assalamu alaikum. Students, today we are starting the configuration of potassium, the period for potassium till krypton. We did it in the last lecture from hydrogen till argon, right? And we are doing the configuration on the basis of orbitals, that is 1s and 2s, that one, right? So now we are doing it for potassium, right? And I'm sharing my screen. Just a minute. And the last topic that we were doing is, yes, it's this exactly this page. So we are doing configuration on the basis of energy. So first we are supposed to fill 1s and then 2s and then 2p and then 3s and 3p and then 4s, right? So after 3p, the electron goes into 4s. Once the 4s is filled, the electron will go into 3d. Look, 2, 2, 6, 2, 6, 18 electron. After 18 electron will go into 4s because the energy of the 4s is lower. But once the 4s is filled, the electron will definitely go into 3d. After, look, after 3p, electron enters into 4s. Once 4s is filled, electron enters into 3d. But for S and 3D are very close. Repulsion between 4s and 3d electron make the 4s to be at high energy or out, and like it's outer, it go outward. 4s to be, we can say, to be above 3d. Look, first electron enter here, then electron will enter here. Then there is repulsion between these electrons, and the repulsion make the 4s to go above 3d. How? Look. So what I'm actually doing, I'm cutting this much part of this periodic table. Wait. Yes. Yes, this much. Very good. Now one other thing that I'm doing. Wait a minute. You know what we are doing now? Look. Look. It's 90. So I'm writing the configuration downward, right? Potassium. It's what? 1s2, 2s2, 2p6, 3s2, 3p6. And after 3p6, the electrons will go in what? 4s. So it becomes what? 4s1. So look, it's 2s1, 3s1, and now it's what? 4s1. For potassium, it's what? 1s2, 2s2, 2p6, 3s2, 3p6, and then what? 4s2. Perfect. But you know what happens in scandium? 1s2, then 2s2, then 2p6, 3s2, 3p6, 4s2, 3d1. But what you are supposed to do? You will, due to repulsion, the 4s will be after 3. Like you will write it, but you will fill in this order. Once electron enter into 3d after 4s due to repulsion between 4s and 3d. They are actually very close. 4s is about 3d. Okay? So, how you will write? The perfect way to write is what? 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. 3d1, 4s2. Now, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. 1s2, 2s2, 2p6, 3s2, 3p6, 3. Actually, it's like this. Like after 18, 19, 20, and 23. And now 1s2, 2s2, 2p6, 3s2, 3p6, 3d4, 4s2. And then 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s2. 1s2, like even if I do it like this, wait a minute. 1s2, 2s2, 2p6, 3s2, 3p6, and 3d, and then what am I supposed to write? 4s2. Wait a minute, what I'm doing. 1s2, 2s2, 2p6, 3s2, 3p6, and 3d6, 4s2. Now what I'm doing? Wait, let me. Hmm. Look, what I did? It's 1 is to 2 is to 2p6, 3 is to 3p6, 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8, 3d9, 3d10, 3d7, 3d8, 3d9, 3d10, and then it's 10 and 10. Now, wait, I'm not going to Gallia. Again, there are two exceptions. And the two exceptions are chromium and copper. We explain it on the basis of stability. But look, I can explain. We are going to explain. But this explanation is not in your course. You guys must know that in chromium and copper, the 3D become half filled and completely filled at the cost of 4s electron. Why? Because the 4s is very close. It's the electron of the chromium and the copper. They can put them in any way to become more stable. That's it. And you know, what is our the explanation that we are giving is it's not actually in syllabus. बस आपको सिर्फ पता होना है कि क्रोमियम और कॉपर ऐसे हैं लाइक आपको कॉन्फ़िगरेशन आनी चाहिए आपको ये पता होना कि लाइक ये क्यों है लाइक इस डिटेल में कोर्स में नहीं है ये स्टेबिलिटी और ये सब कुछ नो नथिंग दे आर नॉट गोइंग टू आस्क यू राइट you just must know that they are more stable in this way. And now, the explanation that we are given is correct, but this is not part of the syllabus. We have to just study them as an exception. So, what are the point? The point is, like in chromium and copper. First, let me explain. Chromium, 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 3d4, 4s2, and copper. 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, 3d9, 4s2. Now look. Half filled, orbitals. Half filled orbitals and completely filled orbitals are more stable. Why? As in half filled, there is no repulsion. There is no repulsion, they are single. And completely filled are stable as they don't need electron. Don't need electron. Now, S1 is half filled, S2 is completely filled, P3 is half filled, and P6 is completely filled. D5 is half filled, and D10 is completely filled. Same as the case for F. So there is just one electron. And there are how many electrons? 2, completely filled. P3 and P6. Two, three, four. So half filled, half, no repulsion, completely filled, they don't need electron. Completely filled. Now look at this. You know what they do? It gives one electron to this. After giving electron, this become what? 3d5 and 4s1. Both are half filled. More stable. It gives one electron to this. It becomes what? Completely filled. And the other becomes what? Half filled. Look. Neither half nor complete, but this is complete. And lower, both are half filled. More stable. Complete and half filled. More stable. So what happens actually in chromium and copper, that it is what? 1, and this is what? 5. This is what? In this 1, and this is 10. This is the actual correct configuration. Now, if you look, this is 1s1, then this is 1s2, there is 2s1 after filling. This is helium, like I'm going toward the shorthand. Helium, 2s1, helium, 2s2, helium, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3, 2p4, 2p5, 2p6. Neon. This is neon, 3s1, neon, 3s2. Neon, 3s2, 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Argon. Argon, 4s1. Argon, 4s2. Argon, 3d1, 4s2, 3d2, 4s2, 3d3, 4s2, 3d5, 4s1. There is no 3d4 in ground state, right? Then it is 3d5 going like this way up to 3d10, 4s2. After 3d10, 4s2, the next is what? After 3d10, 4s2, the next is what? The next is what? 4p. So look, it's what? It is. Gallium is what? Definitely, it is 2p1, 3p1. So it should be what? 4p1. This is what? 4p2. This is 10, 10, and 10, and 10. 4p2, 4p3, 4p4, 4p5, 4p6. Done? So if I write the shorthand electronic configuration, what I will do? I'm going to bring the periodic table again down this way. Now it's kind of repetition, but okay. So first let me clean it. Okay. Look. It's what? First S1. Let me tell you. No, it's very big. We know it's what? S1, this is S2, this is D1, this is D2, this is D3, this is, it's actually D5 S1, D5 S2, D6, D7, D8, and now this is not D9, this is D10 S1, and this is again D10 S2. And this is what? P1, then P2, then P3, then P4, then P5, and this is all P6. Now, in shorthand, what you are supposed to do, helium, this is what? Period 1, this is period 2. This is period 2. So helium, 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 2s1. This is helium 2s2. The helium is bigger than 1s. I guess shorthand, but okay. Helium 2s2, 2p1, helium 2s2, 2p2, helium 2s2, 2p3, helium 2s2, 2p, what, 4, and helium 2s2, 2p, 5, and helium 2s2, 2p, 6. Now, next is what? Neon. It would be what? Neon. Neon what? 3s1. Neon 3s2. Neon 3s2, 3p1, neon 3s2, 3p2, neon 3s2, 3p3, neon 3s2, 3p4, neon 3s2, 3p5, neon 3s2, 3p6. Now argon. Argon 4s2, 4s1. This what? Argon 4s2. Now what I'm doing, wait a minute. Argon 3d and 4s2. If I copy this, what should I do? I'm making it red and I want to put Okay. Video. And now manganese, iron, nickel. Look, now it's fast. Okay, it's a bit small, but I think it's okay. It will help you. So, how you are going to do? It's what? 3D1, 3D2, 3D3, 3D4. I think I should go with red. Doesn't look good. 3D1, 3D2, 3D3, 3D4, 3D5, 3D6, 3D7, 3D8, 3D9, 3D10. Now, where are the two exceptions? Are the two things that change for stability? One electron transfers from this to this, and it becomes what? 3D5 4s1, and the copper is what? 3D10 4s1. And now they are all 10, 10, and 10. They are all the D is filled. And you have to write what? 4s2, 4p1, 4s2, 4p2, 4s2, 4p3, and then 4s2, 4p4, 4s2, 4p5, 4s2, 4p6, and right? It's almost the complete configuration. Now, one thing that you must know. All group 1 has one unpaired, and no unpaired. D1, if you look at D1, one unpaired, D2, two unpaired, D3, three unpaired, D5 and the 6 unpaired, and then 5 unpaired, 4 unpaired. Like, look, you must know about the number of unpaired electron. Where I can make this more clear. I don't want to write it again and again. Look, if the valence is, if the valence is, if the valence is NS1, NS2, so big, sorry. If the valence is NS1, NS2, and then what? Like, suppose 3D1 4s2, 3D2 4s2, 3D3 4s2, 3D5 4s1, 3D5 4s2, 3D6 4s2, 3D7 4s2, 3d8 for S2, 3d10 for S1, 3d10 for S2, and then if it is what? NS2, NP1, NS2, NP2, NS2, NP3, NS2, NP4, NS2, NP5, and the last NS2, NP6. Now, what are you thinking? Actually, this is group 1, group 2, group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11, group 12, group 13, group 14, group 15, and group 16, and group what? 17, and group 18. The topic is what? Unpaired electron. The topic is what? Finding. And why? You will think that why I'm telling you this. Wait a minute. Finding what? Unpaired electron. Unpaired. Now, in S1, there is just one unpaired. Huh? S2, no unpaired. Now, if you look, one, two, three, four, five. Actually, there are too many questions on this. Now, what am I supposed to do with this? No. This is P6. Now look, this is one unpaired. My writing is so bad. I think I'm tired, huh? Unpaired electron. One? No. But in this is 1s2. So 1, this is 2. So 2 unpaired. Now, how many unpaired? 3. If it is D5 and S1, 6 unpaired. They're all S2. Now in copper, only it's what? S1. This is also D5, S2, 5 unpaired. This is D6. So how much are unpaired? Just 4. Now it is 7. So how much unpaired? 5, 6, 7. 3 unpaired. If it is 8, 5, 6, 7, 8. 2 unpaired. And in this, the D is completely filled. The D is completely filled. 1. And is there any unpaired electron? No, 0 unpaired. Now when it comes to P block elements, if you look, the group 13, which we used to call group 3, it's 1, P2, it's 2 unpaired, P3, 3 unpaired, P4, 2 unpaired, P5, 1 unpaired, and P6, 0 unpaired. So can you see the group 0, 0 unpaired, the zinc series, the group, which is group 12, 0 unpaired, and group 2 is also having 0 unpaired. So you must know 1 unpaired, 0 unpaired, 1, 2, 3, 6 unpaired, 5 unpaired, 4 unpaired, 3 unpaired, 2 unpaired, 1 unpaired, 0, again 1 unpaired, 2 unpaired, 3 unpaired, again 2 unpaired, again 3 unpaired, 2 unpaired and 1 unpaired and 0 unpaired. Like why I'm telling you this, if you go to questions, look at this. Not this. Look, there are so many questions about the pairs and unpaired electron. Look, unpaired electron, unpaired p orbitals, and like you must know how to count the unpaired electrons. 3 unpaired, like you must know how to do it. Unpaired, like there are too many questions about the concept of, look, this is unpaired and paired. You must know all this. Therefore, I've done it for you. Okay. And I think after watching these 3 recorded lectures, you won't be having any problem in configuration. Yes, I agree. There are certain points that you will find that these are not completely explained. You know, this is actually quantum mechanics when we talk about quantum shells. I think we are teaching you up to the age of A levels. So up to this point, this is sufficient. Like if you will study them more, you can find something. There's too much to understand. How to calculate the radius of the shell, how to calculate the energies of the shell. We can even calculate energies, the energy differences. All these are possible. But you know, up to your age, this is more than enough, right? And I hope you will be able to do all the questions, at least up to 80% questions. If you can't solve 80% question on any lecture, keep in mind, you don't have concept. You have to do it again. Like, don't learn by doing past papers. Use past papers, use topical to check that did you understand that topic when the teacher was teaching? If you understand, you would be able to do up to 80%, 20% is okay. There are problems always. You can't score 40 out of 40 in MCQs. They're very hard. The MCQs of atomic structures are hard. Why? Because they ask question about paired, unpaired, like sometimes even if you know, and if you are in stress, you know, but you are in stress, automatically your thinking power reduces because of the stress. And you won't be able to, like, sometimes you know everything and still you're not in a position to do it, right? This happens only in atomic structure, not in every chapter. In atomic structure, I've seen that sometimes in bonding, like lone pair, unpaired, shared pair, bond pairs, like I have seen students confuse between unpaired and lone pairs. Lone pair we use in bonding, that this pair is a bonded pair and this pair is not bonded, so we count it as a lone pair. But what is unpaired? Unpaired means a single electron in an orbital. Okay, see you. Allah Hafiz.